Welcome to our channel. Today, we're back with a brand new topic just for you. Before we start the podcast, please don't forget to subscribe to our channel and hit the like button. Enjoy the show.
Welcome to the deep dive. Today, we're jumping into the Rust programming language.
That's right.
What's the big deal here? Well, it promises memory safety without needing garbage collection, which is interesting.
Yeah, and serious speed.
Serious speed, exactly.
Yeah.
And making concurrent programming, well, less scary. Fearless concurrency, they call it.
Mm-hmm. It tackles those classic frustrations, crashes, security holes, data races.
We're drawing on an introduction to the Rust programming language from Code Talk today. Our mission, to really get under the hood, understand Rust's key features, and figure out why it's gaining so much ground. A bit of a shortcut for you, the listener, to get up to speed.
And it really is quite compelling, this combination it aims for.
Yeah.
Safety, speed, and that fearless concurrency.
Mm-hmm.
It aims to prevent those errors that cause crashes, security issues,
Right.
plus the raw speed you'd expect from something like C++ may, and handling multiple things at once without those awful data race headaches.
Yeah, anyone who's spent hours debugging those kinds of problems knows how appealing that sounds.
It's definitely a breath of fresh air, or at least that's the promise.
Okay, so origins. Where did this ambitious language actually spring from? So source mentions Mozilla Research 2010. That's a fair while ago now.
It is.
What was the spark? What specific problem were they trying to crack?
Well, the Code Talk piece points to the big persistent issues, memory bugs, those really nasty ones.
Oh, yeah.
And race conditions in concurrent code, plus generally unsafe code you often saw in languages like C and C++.
The traditional systems languages?
Exactly. Graydon Hoare, the original designer, his vision was to blend that low-level control you need for systems work, but with a really strong safety net built right in.
So power and safety.
Right. Empowering developers, but without that constant fear of memory corruption, dangling pointers, all that stuff.
Okay, getting the best of both worlds then. The control of C++ A maybe, but without constantly looking over your shoulder for memory bugs. And it obviously didn't just fizzle out. The source notes version 1.0 in 2015, that feels like a key moment.
Absolutely. That 1.0 release really marked its arrival as a stable, usable language, and adoption started picking up pace.
So to really get why it clicked, we need to define it properly. What is Rust, fundamentally? Code Talk calls it a compiled, statically typed systems programming language. Let's unpack that a bit.
Okay. So compiled just means it gets turned into machine code. Your computer runs directly fast. Statically typed means the language checks your typed integers, strings, whatever, before you run the code. Catches mismatches early.
Okay. Standard stuff so far for many languages.
True. But the real kicker, the central innovation, is achieving memory safety without a garbage collector.
Ah, yes. The GC. That background process in Java or C# that cleans up memory, Rust doesn't have that.
Nope. And that's where this famous ownership system comes in. Our source really highlights this.
Right, ownership. This is the system enforcing memory rules at compile time, you said, so before it even runs.
Precisely. Instead of garbage collector tidying up later, Rust uses a set of rules, checked by the compiler, about who owns what piece of memory.
Like a very strict librarian for memory.
Kind of, yeah. And the compiler enforces these rules rigorously. Then there's this concept of zero-cost abstractions.
Zero cost. What does that mean in practice?
It means these powerful safety features, like ownership and borrowing, don't add runtime overhead. You don't pay a performance penalty just for the safety guarantees themselves.
That's huge. Safety is great, but not if it makes everything slow down.
Exactly. And this ties into the other big promise, fearless concurrency.
Sounds bold. How does it deliver on that?
Again, it's down to the type system and the ownership rules.
Oh.
They prevent data races by controlling how different threads can access shared data.
Data races. Those are when multiple threads mess with the same data unsafely, right? Hard to debug.
Notoriously hard. Rust's compiler basically stops you from writing code that could lead to a data race in the first place. That gives you the confidence, the fearlessness to write concurrent code.
Okay. Origins and core ideas make sense. Let's talk advantages. Why pick Rust? Memory safety without GC is top of the list in our source. Can you walk us through ownership, borrowing, and lifetimes again? How do they work together?
Sure. So ownership, simple rule, every value has one owner. When the owner goes out of scope, leaves its block of code, the value is dropped, memory freed, clean.
One owner only. Okay.
Now, if you need to use data owned by someone else, you borrow it.
Borrowing. Like asking the librarian.
Yeah, maybe. You can borrow immutably, read-only,
Yeah.
potentially many times at once, or you could borrow mutably, read-write, but only one mutable borrow is allowed at a time.
So no simultaneous writers and no writing while someone's reading.
Exactly. The compiler enforces this. It prevents using data after it's freed, use after free, or pointing to nothing, dangling pointers, and lifetimes. They're like annotations the compiler uses to ensure borrows don't live longer than the data they point to.
Wow, so it catches all these potential disasters before runtime.
That's the goal. All checked during compilation. Hence, zero cost at runtime.
Incredible. Okay, next advantage, performance. On par with C and C++ day, the source claims. How?
Well, like we said, it compiles to optimize machine code, and critically, no garbage collector pauses.
Right, no unpredictable stop-the-world GC cycles.
Exactly. You get fine-grained memory control within the safety rules, allowing for really efficient code, perfect for performance-critical stuff.
Makes sense. We've covered fearless concurrency already. What else makes Rust attractive? The source mentions tooling.
Yes, the ecosystem and tooling are often praised. Cargo, in particular,
Ergo.
Rust's package manager, and build tool. It handles dependencies, building your code, testing, publishing. It's really well integrated and user-friendly, a huge plus.
Good tooling makes a massive difference.
It really does. And another thing people love, the compiler's error messages.
Oh, how so?
They're famously helpful, often explaining why something is wrong and suggesting fixes. Especially for complex things like lifetimes, it can really guide you. It lowers the frustration level, particularly when learning.
That's definitely a selling point. Less time banging your head against the wall. And finally, adoption. The source name drops Dropbox, Microsoft, Amazon, using it in serious projects.
Yeah, that's significant validation. When big tech uses a language for critical systems, it shows maturity and builds confidence in the ecosystem. It also fuels more development, more libraries, more community support.
Okay, so we see the why. Now, the where. Where is Rust actually being put to work? Systems programming seems like the obvious first answer.
Absolutely. It's a natural fit. Operating systems, parts of kernels, embedded devices, firmware,
Yeah.
areas needing low-level control and safety. It's replacing C and C++ in some of these really critical areas because it avoids those common memory pitfalls.
And WebAssembly or WASM, that's interesting using it for the web.
Yeah, you compile Rust to WASM, and you can run near-native speed code inside a web browser. Great for heavy computation, games, complex applications right there on the web, stuff that might be too slow in JavaScript.
Command line tools are also listed. Fast, safe, cross-platform.
Makes perfect sense. You want your CLI tools to be quick and reliable everywhere. Rust's speed and safety, plus easy cross-compilation, makes it ideal for building robust utilities.
Networking and web servers, too, with frameworks like Actix and Tokyo mentioned.
These async frameworks leverage Rust's concurrency features to build really high-performance servers that can handle tons of connections safely and efficiently, crucial for modern web backends.
And the source also mentions blockchain, cryptography, and even game development. High-stakes areas for performance and correctness.
Exactly. Blockchain needs efficiency and security. Rust delivers. Crypto relies on correct, safe implementation. Rust helps prevent bugs that could be security holes. And in games, that raw speed and memory control are increasingly appealing.
So it's really branching out. But it's not all roses. The source is honest about challenges. What are the downsides or hurdles?
Well, the big one everyone mentions is the learning curve. It is steeper than many other languages.
Particularly ownership and borrowing.
Yes. Those concepts are powerful, but they're different. If you come from a GC language, it's a whole new way of thinking about memory. It takes time and effort to really internalize it.
Fair enough. A different mental model.
What else?
Compile times. They can be longer.
Why's that?
Because the compiler is doing so much work checking those safety rules and doing heavy optimizations. It pays off in the end with safer, faster code. But yeah, the build step can take longer than you might be used to.
A trade-off then.
Yeah.
Compile time versus runtime, safety, and speed.
Pretty much. Also, the ecosystem, while growing fast, is still younger than, say, Java's or Python's.
Meaning maybe fewer ready-made libraries for every possible niche.
Potentially, yeah. You might find yourself needing to build something that would already exist in a more established ecosystem. But Cargo makes using libraries easy, and the community is incredibly active, filling gaps all the time.
Okay. And the syntax. The source says it can be verbose sometimes.
It can be. To achieve that explicitness and safety, you sometimes need to write out type annotations or those lifetime specifiers we mentioned, making the code a bit more noisy.
Maybe at first glance. It adds clarity in the long run, proponents argue. but it can look a bit verbose compared to languages that infer more things implicitly.
Got it. So challenges exist, but the outlook seems bright. Code Talk mentions it consistently topping most loved language surveys. That's pretty telling.
It really is. Developer happiness is a strong signal. People enjoy using it once they get over the initial hump. And the language keeps improving. Async support is getting better and better, for instance.
And with that growing industry adoption.
Yeah, it points towards Rust becoming, a really foundational language for building safe, performant software for the future.
So who is Rust really for? Who should consider learning it? The source gives some pointers.
Definitely systems programmers who need that control but crave safety.
People building OS components, embedded systems.
Right. Also, anyone working on performance-critical apps, web backends, game engines, scientific computing. If speed matters, Rust is a contender.
What about concurrency?
Absolutely. If you're dealing with parallelism, multi-threading, and want to avoid those awful race conditions, Rust's fearless concurrency is a major draw.
And folks focused on security and correctness.
A prime audience.
Yeah.
The memory safety guarantees eliminate entire classes of common vulnerabilities. So, security-conscious developers should take a look.
Lastly,
People wanting to contribute to cool open-source projects. The Rust ecosystem is vibrant, welcoming, and working on cutting-edge stuff.
okay, so wrapping up our deep dive, Rust clearly presents this really compelling mix. Performance like C++ may, but with strong safety guarantees built in. It tackles some really old, hard problems in programming.
It really does. It's a different approach, especially to memory and concurrency. It challenges developers to think differently, but offers significant rewards in terms of reliability and speed. Powerful and reliable software.
So here's a final thought for you, our listener, to chew on. Considering Rust's intense focus on safety, on performance, on catching errors before they happen, how might these core ideas like ownership, like compile time checks, start to influence other languages? Or even how we design software systems in general in the future? It's a fearless way to code. What could the ripple effects of that mindset be? Thanks for joining us for this deep dive.